Hi all, it's the 31st of January 2023, and today we're going to take a look at the severe ice storm that's ongoing across Texas and into the Midwestern states associated with this cold frontal boundary, which is just lingering and being very, very menacing over this region. You can see it's actually coming in at mid-levels all the way from the Pacific over the Mexican highlands and into Texas. We'll take a look at the forecast and then we'll look at why is this occurring? What is freezing rain? Why is it occurring? And when will it end? If we take a look back at the last day or two, you'll see this big plunge. It's associated with this huge trough in the jet stream that is quite deep in the troposphere and spreading throughout from the tropopause down to mid-levels. And this is bringing in moist air. The mid-level air is quite warm as it comes up over Texas, and the issue is that it's overrunning at low levels. The flow is light northerly coming down, tucking under this warm air is very cold air coming down like this, and so you've got warm air above cold air and warm air producing rain falling into cold air over below freezing surfaces, which is causing the freezing rain. We'll go into this in more detail in a moment, but let's just check the forecast. This is the HRRR, which is a high-resolution weather model, and because of that, it only goes out till Thursday, but that captures the main brunt of the event. The time in Texas is 6 hours behind UTC, and the time down here is UTC time. So the initial time at 17 is actually 11 a.m. in Texas. So what I'm going to do is I'm going to zoom in just one layer more, and so now we've got Dallas down here, Oklahoma City up here, Oklahoma, Arkansas, Louisiana, Texas, Mexico, and let me just draw on the outline of the freezing rain according to this model very roughly. And the reason I want to put this on is because just check out what happens tomorrow. So it's roughly like that. Now I'm going to move forward in the model forecast. As we go through, we'll see the first band of freezing rain spreading off towards the east across Arkansas and then into northern Mississippi. And then we get another big pulse coming through, and this is in about 24 hours from now, so tomorrow at 11 a.m. And look at the extent of the freezing rain. And it's not just the extent, the values are also very high in this model. And if we put a little pinpoint here, we'll see we're getting 16.3 millimeters in 3 hours of freezing rain. It's a lot of accumulating ice. The National Weather Service have said over the course of this event to expect 1/4 to 3/4 of an inch of ice to accumulate. So let's just take this through to the end of the HRR forecast, see what happens. I'm going to get rid of this now. There we go. And it actually pushes up into Oklahoma, the freezing air, rain, and then that's the end of the forecast. So really a widespread region, very large, very dangerous areas of accumulation throughout Texas. Waves coming through, but a really large area coming through tomorrow in the morning. The National Weather Service is fairly blunt with their assessment as to what you should do here, and the best thing to do is to just stay home, wait this event out if you can, but if you do have to drive extremely slowly and carefully. You can see the winter storm warning area matching up quite well with the precipitation that we were just looking at. To see when this event will end, we check out the European Center model that goes a bit further than the HRR. And if we go forward through tomorrow morning, that's that big wave of freezing rain that is forecast to come across central and northern Texas and into Oklahoma later, and then to Arkansas. Beyond that, another round of not quite as severe freezing rain due in as we head into Thursday. But it does look like by later on Thursday, the temperature has picked up a little bit. It's 4 or 5 degrees above freezing, and so we should hopefully see that ice begin to melt as we head into later on Thursday and Friday. However, looks like temperatures do dip down below freezing again on Friday morning. Why is this occurring? The reason it's occurring is because warm air is overtopping colder air underneath, as we've gone through before. It really depends on the height and temperature differences between the layers as to what type of precipitation will fall. If it's rain falling down largely above freezing and then just getting below freezing at the surface, and you get freezing rain. But if the rain falls down and it enters a larger area of colder temperatures, then you get sleet, or American sleet, which is otherwise known as ice pellets. And then if it's below freezing throughout the whole layer, as is more typically the case in wintry precipitation, you'll get snowfall. To get a bit more technical about it, here are some example temperature profiles of what you might get for snow, sleet, and freezing rain, sleet, ice pellets. So snow, the temperature is the blue line, so you just see it going down and decreasing with height, as is more normally the case. For freezing rain, the temperature drops just very quickly, and then it starts to increase in a layer at around 1 kilometer in this example, producing with temperatures above freezing at that level. So you've got warmer air. It's quite unusual. So the air is coming from somewhere that's very warm here and coming from somewhere that's very cold lower down. Sleet is a bit of a in between, but you've still got that inversion, this temperature increasing with height, tipping up a bit above, but not as dramatic a change there. So if we think about that diagram, what we should be seeing over Texas right now that's producing this freezing rain is colder temperatures at the surface. And you can see that here it's -4. This is in centigrade. Abilene -4 at 18 UTC around the present time. Now, if there's that temperature inversion, if we go up a few kilometers or so above the surface, we should see temperatures warmer than this. And you can do this in windy here. Just lift up from the surface. As we go up, it's still below freezing at about 600 meters elevation. If you go further up, we begin to see the freezing levels tucking back a bit, such that even at 1,500 meters here, now we're quite high elevated above the surface, the temperatures are actually warmer than at the surface. The temperatures marked on here are still the surface temperatures, but if I click on here, you'll see that the temperature above that temperature is actually 8 degrees Celsius. Wow. So here at Brady, it's -3 at the surface and 8 degrees at 1,500 meters. So now you can see all that cloud is coming in, bringing rain at elevations above the surface. That falls down and it's -3 at the surface. What do you expect to happen? It's gonna freeze. Given this, the last thing I'd like to look at actually is the weather balloon launch temperature profile, because given what we see in the models, what you would expect to see from the nearest balloon launch is that it rises from below freezing, and then you see this increase in temperature through a layer above the surface. So let's check that out. If you want to check the data coming from weather balloons, then you go to the University of Wyoming. Just Google for University of Wyoming soundings and shift to the GIF SKU-T in type of plot here. And I'm going to go down to Dallas, Fort Worth here. Let's take a look at that. Whoa. Oh my God. Yeah. Wow. So there are a few things to see here immediately, and it's quite dramatic. I mean, really, that is a shocking inversion. So at the surface, these are the temperatures, and this is 0 here, and then this is -10 Celsius. So at the surface, this is the temperature line, and you can see it's around -5 at the surface. We get up just a little bit, and then we see that level we were looking at, 1,500 meters. The temperature increases, and it seems to go almost to 10 Celsius. And then from there, you've actually got to go up all the way up to about 3,000 meters before you start getting back below freezing. And the reason actually can also be seen in this plot quite nicely. We can see the depth of the layer, and the troposphere is essentially divided quite markedly between a huge slab going up to the stratosphere of southwesterly mildish winds, just slabbing over slabbing what is a shallow, cold area with northerly winds at the surface that's tucking underneath. So it really is quite a dramatic sounding, and I think on that I'm going to leave it for the moment. Please let me know if you want to cover more of this event. I've got to move on to some cyclone stuff. See you in the next one.